Hello and welcome everyone. Today we're talking about bias in deep learning. What it is, why it's a problem, and what we can do about it. All right, so what is bias? Well, we as humans, for example, we are all biased. Even if we try to be super objective, even if we're journalists that try to be very, very objective, we are still biased because we all have preconceptions about things. And the same way, neural networks can be biased as well based on what data we feed them. And this can be a problem actually. So let's take a look at how this works. As you know, deep learning requires lots and lots of data. We require this data to train our neural network to find certain patterns to detect things. And depending on which data we feed, this neural network has certain abilities. So let's take a look at how this looks like if we train a neural network to classify animals. So if we want to train a neural network to classify animals and detect dogs, we collect a lot of images of different types of dogs, and we label them and we say this is a dog and this is a dog and this is a dog. So we get lots of these dogs from different types of races. We might have a dachshund, we might have a husky, we might have a German shepherd. So all these kinds of things because they're all dogs and we want to train a network on how to detect dogs. But let's say we have so many different kinds of dogs in there, and then we have one Ibu Shiba. So if we just have one Ibu Shiba in there, then the network will have not a very good idea that an Ibu Shiba is a dog. So that means if we run our network to classify animals and to say if it's a dog or not, when it sees a German Shepherd and when it sees a Husky, it will say with a very high confidence, for example, 90%, that this is a dog. But then it will see an Ibu Shiba and it might have an idea, but maybe it says with a 40% confidence that this is a dog. Because we haven't shown it a lot of dogs, it has this bias towards certain kinds of dogs and another bias towards other certain kind of dogs, because it just was not very well trained, because our data set was not very balanced. It didn't have the same amount of different types of dogs in the data set. Of course, for a network for dogs, it's not a big problem. So let's go into more realistic scenarios on our end. Let's say we want to train a neural network on how to detect people. Well, it turns out that a lot of the public data sets that are out there and that are used to train person detectors are actually from China. So if you just take those, then your data set will be very much skewed towards how people from China look like and won't have a lot of examples of people who look differently from people than people from China. So if you just take that and you have a regular person detector, it might be much more accurate on people that look like Chinese people than other kinds of people. If you, for example, used it for a people counting application, the consequence of this is that the detection, other kinds of people, other people that look different won't work so well. So essentially, you won't count them so often as you would count people that were in your data set. In the example of people counting, it just means that your accuracy drops. That's not a huge bad consequence. Yes, you have a bad model. Yes, you have bad people counting. But other than that, there's not a lot of consequence out there. But think about another application. Let's think about facial recognition. If you, for facial recognition, use data sets that are available, then you might grab data sets that were taken from a criminal records database. And it turns out, well, criminal records, actually all criminal justice systems in the world, because we as humans are biased, are also biased. Just as everybody is biased, judges are biased as well. So it might be skewed into a certain direction. If we're not conscious about bias, we might take these data sets and perpetuate this bias that we already have in our society into our data sets. And then we use this facial recognition system to find perpetrators, and it might be much more accurate on people that were in our data sets that might be from minorities, for example, or other groups of people. So instead of having a computer that's very objective, we have a computer that's as subjective as ourselves, and we just perpetuate these biases we already have. So this is why it's important to be very conscious about biases. It's important to recognize that they exist. It's important to recognize that we can never train a neural network that's 100% objective without bias. But we can do things about it. And the things that we do about it is called balancing of the data sets. So what we do is we look at all the different kinds of classes or types of objects that we have in our data set to train our neural network. And we try to see that they're balanced out. So we have the same amounts of German Shepherds, we have the same amount of Huskies, we have the same amounts of Ibushibas in our data set, so we know it's as objective as possible. And we try this with many different types of combinations in our data sets that might be important. So while it's not possible to completely remove bias from our data set, it's important to make a conscious decision and a conscious effort to remove bias as much as possible. And anyone who is training neural networks out there should be conscious about it and have a constant effort to balance their data set and remove bias as much as possible. That's it. I hope you enjoyed this episode on bias. It's a topic that's very important and near and dear to my heart. It's very important for anyone who is training neural networks. So be conscious about it, and I hope we raise awareness with this video a little bit. Otherwise, thank you for watching. Don't forget to subscribe as always, and otherwise, see you next time.